Good morning, everyone, and I would just like to remind you that you have a test coming up on Thursday. I would like to go through a couple of the key vocab words for the chapter. Remember that a point is a location in space. It has no dimension, no size, just a place in space. A line is when you connect 2 points, the straight line between them, it goes on forever. It does not have a width or dimension, but goes in a straight line forever and ever. A ray starts at a point and goes in another direction forever. So this one would be ray DE. We start at the vertex at the end point and we go through point E. This ray would be ray FG. There's no other way to name these two rays. You have to start at the end point. Down here we have a segment. A segment has 2 endpoints. This would be segment IH or segment HI. Either way for a segment. As we move on over here, we have an angle, and an angle can be named by its vertex K, so we could call this angle K. We could call it angle JKL, or we could call it angle LKJ. Notice in all of these, the vertex K is in the middle. Our last vocab word that I'd like to talk about is a plane. And a plane goes forever and ever as a flat surface in all directions. We call a plane by 3 points. 3 points make up a plane, so I have them labeled here. This could be plane NOM. You could say ONM or any combination. The order of the 3 points does not matter. So those are the main vocab words we had for this chapter. Moving on, we talked about different types of angles. And an angle with a measure of 0 to 90, we have a small angle. Remember we said that's a really cute angle or an acute angle. An angle that is exactly 90 degrees is right on. That is a right angle. An angle with a measure of 90 to 180, up to 180, is an obtuse angle. Remember, obtuse and obese means a big angle. And where 2 lines meet, the angles opposite of each other that share the common vertex but do not share a side, we call those vertical angles, and vertical angles are always congruent. See that they're marked congruent here. In this same picture, I would like to talk about the angles that create this straight line also. We call those a linear pair. Okay, so that would be angle 1 and 2 would be a linear pair. The red congruent are vertical angles. And last, we did talk about a reflex angle being outside of the normal angle that we usually talk about. Points A and B lie on the line 2x minus 3. Which of the following coordinates are non-collinear? Well, non-collinear means lies on the same line. So we're going to plug in the points to see. Okay, go ahead and pause to see what that answer is. Notice as I worked out each problem, I plugged in the x value for x and checked for the y value. The only one that is non-collinear here is C. When I plug in negative 2, negative 2 times 2 minus 3 is negative 7, not negative 10. So C is non-collinear. Moving on here, point E is the midpoint of DF, and in DE and EF we know the values. So we have to find the value of x. The first thing we want to do here is sketch. We know point D, we know point F, and we know point E is the midpoint, which tells us that these two segments are the same. Pause the video here to try this problem. So as I set the 2 portions, the 2 segments equal to each other because the midpoint is in the middle, I found that x equals 2. That would be the answer to this multiple choice question. However, looking at this a little more carefully, if I plug 2 in, 3 times 2 plus 7 equals 13, that verifies with 8 times 2 minus 3 is also 13. So I could also tell you that DE is 13, EF is 13, and the total length of D to F would be 26. So we know a lot more about this problem. Yesterday we talked about polygons. A two-dimensional closed figure of a straight line segment is a polygon. Has to be a closed figure here, and it has to be a plane, which we call two-dimensional, and segments are the sides. From here, moving on, a polygon with all sides equal and all angles equal, we call that a regular polygon. Okay, thinking about the words equal sides, we call that equilateral. Equal angles, we call that equiangular. A polygon with four sides is a quadrilateral, quad meaning four. 5 sides is a pentagon. Pentagon is in the U.S. Capitol, in Washington, D.C. 6 sides, remember that has an X, that's a hexagon. 8-sided, think about an octopus, that's an octagon. The two I want you to remember, 7 is a heptagon. There's no easy way to remember that. 9, how do you spell 9? N-I-N-E, so that's a nonagon. Those are two that are a little tougher to remember. The point where two sides of a polygon meet, we call that a vertex. Think about that as the corners of your polygon. And where the two vertices, what connects them, we call that the diagonal. Those are the non-consecutive connections, okay? That would be my room across from Mr. Haas's room. We are not next to each other, so it's a non-consecutive. Finally, finishing up a couple of true-false questions. A heptagon has 7 congruent sides and 7 congruent angles. That is sometimes true, only if it's regular. If it's just a heptagon, we don't know anything about the sides or angles, we just know that there are 7 of them. Planes extend infinitely in a flat surface. That is true no matter what the situation. And lastly, equiangular nonagon. Equiangular means all the angles are equal, and nonagon means 9 sides. So 10 is incorrect. It should have 9, and it should not be equal sides. It should be equal, angles. Spelled that one wrong. So this one is angles, and 9 of them, not 10. So this one was false. Good luck in studying for your test on Thursday, and I will be back Thursday.